Valves, heart valves. What is their function? Quite simply, they're going to prevent backflow. They're going to prevent things from going the wrong direction. In the circulatory system, the entire circulatory system, including the heart, the blood should be flowing in one direction only. You may already know that the heart sounds that you can hear in a stethoscope, those are actually the valves closing. That's what makes heart beat, or at least the sound of a heartbeat. So in order to demonstrate these valves, I'm going to make my crude drawing again. That is a strange squiggly line. Okay, that's good enough. And then we've got a vessel that makes a little T here. So this is the right side of the heart. See if we can make everything connect the way it's expected to. And then we're going to draw the other chamber over here. And I need a space for, oh, okay. That is not perfect, but it's good enough. Okay, so the first valve right here. Blood is going to flow from the right atrium into the right ventricle, and it has to go through this valve. And valves have these flaps called cusps. They're just sheets of tissue. Most valves actually have 3 cusps, with one exception. This particular valve, I cannot draw 3 cusps very well, but if you can imagine a third one. This one is sometimes called the tricuspid. The reason I do not like that name is because most of the valves have 3 cusps, so that's not terribly unique. But nonetheless, that's one of the names for this particular valve. It's not my favorite name. My favorite name for this particular valve is the right atrioventricular valve. Now, granted, it is a longer word. You can actually abbreviate this atrioventricular as AV. So right AV valve. The reason I like it, it tells you exactly where it is. Right side between the atria and the ventricle, and it's a valve. So I like that name the best, but this name is also totally acceptable. Our next valve goes between the right ventricle and, it's hard to draw these, and this vessel here, which the T vessel, hopefully you remember that's the pulmonary trunk. And this particular valve right here, that valve is called the pulmonary semilunar, because apparently the cusps looked like half moon to anatomists. So that's the pulmonary semilunar right here. And then we're going to go over to the left side. Pretty closely mirrored over here, actually. So we've got this valve here, and blood, those are strange cusps, but blood's flowing from the left atrium to the left ventricle. This valve, my favorite name, would be a mirror of this name, left atrioventricular valve. Easy. However, this one is also sometimes called the bicuspid because it's the only valve that only has 2 cusps. All the rest of them have 3, even though that one's called the tricuspid specially, and these semilunars are not. Nonetheless, bicuspid is an accurate description of that valve. There is a third name, the mitral valve, which apparently is the most common term used in clinical settings. I had a student who worked in the cardiology department up at the U, and he said mitral valve was what they always used for this particular, the left AV valve. And mitral is going to be an obscure reference that I doubt many of you know. It's named after the hat that Catholic bishops wear. So Catholic bishops wear this hat that has 2 flaps, and it apparently looks a lot like the bicuspid valve. So, and that hat's called a mitre hat. So the mitral valve is named after a bishop's mitre hat. Not something we really know in our world today. Catholic bishops don't tend to wear those anymore. Anyway, so 3 names for this one valve. Any name is fine. Any of those 3 names. If you labeled it that on the exam, that's totally fine. And then our last valve goes between the left ventricle and the aorta. And this one is also a semilunar. It's called the aortic semilunar. So notice that both the semilunars are named after the vessels that they go into, the pulmonary and the aortic. And then if it's convenient to you, you can just memorize left AV, right AV, and that makes the valves a little bit more straightforward, I guess. And here, I have a list full of the valves that we just learned, and I indicated that the extra names there as well. One other thing here that is important to note is the chordae tendineae, which is only on the AV valves. What on earth is that? Well, there it is. The chordae tendineae are really strong cords, literally, that come off of or attached to the valve cusps. And the other end of them is attached to this hump right here. This right here. There's another one back there. It's kind of like a column of muscle like that, and you would have these strong cords attached to the muscle, and at the other end would be attached to a valve cusp. These chordae tendineae and papillary muscles together, they will prevent the cusps from being forced back into the atrium. So what can happen is in the ventricle, especially the left side because it's so big, you can get a lot of pressure inside of this chamber. And if you didn't have the chordae tendineae and papillary muscles, what would happen is these valve cusps, these white sheets, could literally blow back into the atrium like that. And that's bad because that's going to prevent the valve from doing its job. The valve's job is to, the valve's job is to make sure that blood only flows this direction and then it never goes back the other way. But if those valve cusps get blown back into the atria like that, well, the blood is going to then probably flow the opposite direction. So instead of going from ventricle to blood vessel, that's not shown here, it would go from ventricle back to atrium, which is the opposite of what you want. You're backpedaling. You're losing ground there. Okay, so if we look at the internal anatomy, here we can see all these valves and the chordae tendineae and papillary muscles. So the white part is the valve cusps. Those little narrow white, or those little white lines, those are the chordae tendineae. And you can see the papillary muscles. Papillary, by the way, means finger-like. And I'll color them in blue too. Those columns of muscle that are holding those chordae tendineae. And so this is the right AV valve, because we're in the anterior here. I know that's hard to tell, but if I can see the superior and inferior vena cava on this side, it must be on the right side of the heart, and thus right side is more anterior than left. So this is the left AV. Now notice that this here is the pulmonary semilunar because it's going into this trunk. You can barely see the aortic semilunar back there. Notice that the semilunars do not have chordae tendineae and papillary muscles. And there's a good reason for that. So you think of arteries being under high pressure, and they are as compared to, say, veins, but the highest pressure is in the ventricles. So keep in mind, the ventricle is actively pumping. It's pumping hard. So the pressure buildup inside these ventricles is very high. And so it ejects the blood into the artery. And then the artery, while it does have a smooth muscle layer in its wall, it doesn't generate a lot of force. It is not actively pumping. So the pressure here inside of the artery is much less than the pressure inside the ventricle during contraction. So what that means is this pressure inside this artery is not near high enough to push these cusps back into the ventricle. So you don't need to worry about the semilunars. They're good. They're not under high pressure, but the AV valves definitely are. Okay, other things, internal anatomy. I'm gonna actually throw up everything. So, just FYI, we have dealt with those two things already. We've talked about those. Let's talk about these two things, pectinate and trabeculae carneae. They're both referring to something very similar. If you look inside the ventricle, you can see this ropey wall. And then if you look inside the atria, you can see a little bit of ropey wall there as well. In the atria, we call that ropiness pectinate muscle. And in the ventricles, we call it trabeculae carneae, which literally means just like meat ropes. That's what trabeculae carneae means. And it does look ropey and weird. Now, don't confuse it with the papillary muscles, which are, sometimes it can look sort of ropey in there as well. Papillary muscles are always attached to chordae tendineae. Trabeculae carneae, this other ropey weird stuff back here, it's not attached to cords. So it's just the meat ropes, not the papillary muscle. Okay, and that leaves, that's a mess. That leaves us with the septum. That's important. The septum means wall. So you have a nasal septum that divides your left and right nasal cavity. You also have septum that divide up the chambers. Now, when I made my crude drawing of heart chambers. I did not connect the atria because I needed to squeeze some vessels in there. But in fact, if I was going to draw a more anatomical version, it would be, 2 ventricles down here, 2 atria up here, and the atria share a wall and the ventricles share a wall. So the wall between the atria is called the interatrial septum, and it's kind of this area right here. Whereas in the left, if you can imagine the left atrium's on the other side of that wall. Whereas the interventricular septum, you can see really well here. It's this wall between the right side would be over here. Sorry, it's kind of busy. Right side over here and left ventricle over there. And that's the wall between them, the interventricular septum. Okay. Oh, probably good that I erased everything. I was getting busy. There is one thing inside the interatrial septum that I want you to take note of. It's this right here. It's like a depression, an oval-shaped depression inside the, or part of the interatrial septum, part of that wall. That little oval depression used to be called the foramen ovale before you were born, because it is in fact a hole. So if you remember, foramen means hole. So in a fetus, that's a hole. As soon as you're born, a flap of tissue comes along and closes it up. It'll heal over, and then it's just a depression. Why in a fetus do you have a hole? Well, I'll tell you why. Because the blood doesn't need to go to the lungs in a fetus. They're not using their lungs yet. You don't use your lungs at all until you're born and you take your first breath. That's the first time you use your lungs. So you don't really need to send blood to the lungs to pick up oxygen, because it's not going to pick it up there. It picks it up through the placenta from mom. So when blood returns, changes to blue, into the right atrium from the body, normally it would then dump into the right ventricle, etc. But in a fetus, it doesn't need to do that. So instead, it comes into the right atrium, and then it goes through this hole to the, doesn't go to the pulmonary trunk, it goes to the left atrium back there, and then goes through the left ventricle and through the systemic circulation. So ideally, very little blood, a little bit, but very little blood is actually making its way into the right ventricle and onto the pulmonary circulation. Very little blood until you take your first breath. And then there's all these pressure changes. I won't get into detail, but basically, inhaling causes this vacuum that'll literally draw the blood through the pulmonary vessels. And also it causes this flap of tissue to cover up, to kind of suck into place over that hole, and it becomes then the fossa ovale.